have any questions during the webinar, feel free. You can raise your hand and you can kind of jump in, or you can send those to my email at asmith@hbmcclure.com, or you can include those in the chat. So my name is Adam Smith. I'm Vice President of HB McClure Commercial Service, and we have locations in Mechanicsburg, Harrisburg, York, and Lancaster. Really excited for today's presentation, and we'll have two of our engineers, Mark Graybill and George Peters. Really just, and it's not so much focused on, just bipolar ionization, which is one of the tools that we believe in to be a part of a solution. And that's not to suggest that we have the solution. We don't necessarily believe that that's out there. But really today is about education. It's about collaboration with our clients, helping you understand some of the things that you can do to maintain a safer workspace. And Mark and George are both really passionate about this, have done an awesome job kind of working through this as things kind of changing daily. But thanks so much for being here. And with that, we'll turn it over to George and Mark, and they're going to jump in. Take it away, guys. Yes, sorry for the delay here, guys. Mark or George, are you guys on? Yeah, give us just a moment here, please.
There we go. Are you able to hear us now?
We've got you, Mark. Thank you.
Okay. All right. Thank you for joining us. We're here to talk about tools for a safe and healthy workspace and the strategies that we see that can combine together help protect everyone in the workspace. So ASHRAE came out with the statement a number of months ago that the transmission of SARS-CoV-2 through the air is sufficiently likely that airborne exposure to the virus should be controlled, and that changes to building operations, including the operation of heating, ventilating, and air conditioning systems, can reduce airborne exposures. So that is really the key to why we as a company are involved in this, that HVAC does have an impact on the spread of COVID-19. And with that, we see three main components, and they all really work together. It's not just one thing alone that can protect the workspace. It's all these working together to make it a safer place. The first is if we can reduce the exposure at the source. We'll talk about methods for that. Then we'll talk about treatment within the room itself, and then how we can treat the air that's getting recirculated. And we'll go through each of these numbers that are on the plan are kind of resembling the different area strategies that we'll be talking about. So what are we dealing with in the first place with SARS-CoV-2? Well, we're dealing with a very small particle size, about 0.1 microns. So that's extremely small. But luckily for us, it's always pretty much bonded to something that's larger. So we hear a lot about aerosols, droplets, and things like that. Basically, what's coming out of your mouth, what's coming out of your nose, when you're speaking, when you're coughing, sneezing, singing, any of those types of things. So you're exhaling, and with that liquid that basically comes out, if you have the virus, that's also bonded to some of that liquid. So our goal is to stop that as much as possible. Stop or catch it before it can go from you to someone else. So the one helpful thing is that it's always bonded to something larger. At the end of the text there, it's saying pretty much everything that's bonded to is 1 micron or larger. So if we look at this chart on the very top, I highlighted 2 lines up there. And if we're looking at sizes that are 1 micron or larger, one of the little bit scary things is that it takes a while for those to settle. So if you have something that's 1 micron, it could be lingering in the air for 19 hours before it would be able to settle 8 feet. Now, that's if the air is still. If the air is moving, it's going to take even longer. In the past, one of the main things that they've talked about, or policymakers of, say with our typical 6 feet of distance, is worried about the largest droplets. So those would be the ones that are even larger than this 1 micron and 10 microns. They'll settle out very quickly within that, say, first 6 feet. But if you're coughing or you're sneezing, or we're dealing with these smaller particles, they're going to go a lot farther. So that's when it's going a lot farther, then that's something that we can deal with some with the HVAC system. So how can we reduce exposure? That's really where masks or face coverings come in. Or I should say, in addition, if you're sick, don't go out, don't go to work, stay home. Basically, how can we keep the source out of the workplace?
Yeah. Excuse me, and I'll just add to that a little bit. Really, in the scheme of things, I think this is where a lot of the heavy lifting gets done. You know, it's like any strategy. If you don't want it in your house, don't let it in the door. And that's where, you know, good judgment and personal hygiene really weigh into it. So I you know, comparatively, this is still some of the most important stuff from the operation of your building. This is a big item.
So here's just an example of masks and kind of how that source capture occurs. So the actual percentage that a mask will stop, that's a good question, but it will definitely stop something, and it will reduce how far the particles will travel from you. And one of the really interesting facts is the study that, or there's multiple studies, but this particular one from the Cleveland Clinic states that if you're in a place where people are wearing masks, the risk of the spread of infection goes down 4 to 5 times. So it's just a tribute to how much of a difference it makes. So we still have to deal with anything that gets passed. So you still have people in a space, you still have a certain amount that gets past a mask, or if people aren't wearing masks, you still have the stuff that's coming from them. So how do we deal with what's already now in the air around us? Well, there's only so many options. And there's not too much if we're looking at from point A to point B, between 2 people in the same space. Well, the air can go between us before it ever gets back to the HVAC system. So we'll talk about what are good options and what are not so good options, and which direction we've decided as a company to go. So first, unfortunately, we can't just spray a disinfectant into the air, but there are good disinfectants that can be used on surfaces. So here's one website with the EPA that has disinfectants that are good for dealing with surfaces, any type of surface. It's just not something that we can put into the air. UV. UVC is a particular particular wavelength of UV that is very effective, but it has side effects. Here are other examples of UV that that people have looked at using in spaces, but there's some effectiveness and safety concerns with these two in particular. So they've looked at using it's called a near UV within a space, integrated into the lighting system, and use that for disinfecting, but it's not very effective. Or they've looked at using far UV, but it requires a lot higher dose, and you're getting closer to the damaging types of UV for people, and it could still cause damage to eyes and skin. So UV within the space down towards people isn't really an option. There are other types of UV that you can mount high on a wall and it just stays up high. That can be an option, but it's not something that we see as the main go-to method. Photocatalytic oxidation. This has been around for a while. You typically see it goes into an air handling unit, has a UV light in the center, surrounded by like a perforated metallic mesh around it. And so ASHRAE has a position on that there's a number of downsides. It can generate ozone, and it can sometimes create byproducts that are worse than the original things it was trying to deal with. So that's not a direction that ASHRAE advocates or that we're advocating. And then there's bipolar ionization. So in some ways it's a newer technology, and it's something that ASHRAE doesn't have a particular position on it yet, and the CDC doesn't either, but they see it as an emerging technology that has a lot of potential, but they aren't ready to give a firm endorsement. So the biggest caveat they say is, if you use bipolar ionization, make sure that it doesn't create ozone, because ozone is definitely bad in just about any amount.
Yeah, and towards that end, the UL 2998 standard, which is a new standard developed. It's actually increased or decreased the requirement for ozone by an order of magnitude. So the previous standard required a 0.05 ppm rate for ozone generation, and this new standard is 0.005. So it really is driving, the current standard is driving the ozone down to virtually zero. And so if you are looking at anybody's technology, really for anything where they're using any type of an arc or light to treat virus or anything else, you want to look at that UL 2998. Should be part of your review process.
So ASHRAE, their epidemic task force, they do recommend installing ionization units in air handling units in schools. And the link that we have on here goes and provides some of the, actually it provides the full guidance that they have for reopening schools and universities. One of the instances where they recommend ionization units, it's really for the air distribution as well as to help with filtration. And we'll talk about later how it actually helps with filtration. We talk about this being an emerging technology. Well, that's one of the reasons why we've gone to the company in that field that has the most experience, that has pretty much the patents on the technology, and has the most engineering backing for what they provide, and that's Global Plasma Solutions. So The example that's here on the page is one of their units, and we'll talk a little bit later about how that works, but this just gives you an image of it. One of the really important things is it actually has been tested against SARS-CoV-2. Been verified through third-party testing that it does kill it. So now it's in a particular situation where it was tested under certain laboratory conditions. So it still has good application in the actual in real life settings. The question will be what percentage it actually kills. In the laboratory testing, it was 99 point something percent. In real life application, I'd like to know what that full percent is, but it's definitely going to be effective. And as we were talking about the ozone, it meets this very strict ozone requirement. And to my knowledge, there's maybe only one other, I think, bipolar that meets that requirement, and the other one just received it within the last month or two. Another important thing is there aren't any negative effects from these ions that get generated by the bipolar ionization. So there's nothing negative that comes from it, and it has the proven positive of destroying SARS-CoV-2 and other bacteria and viruses. So we talked a bit about what it does. How does it do it? Well, it uses these two electrodes. It has one positive, one negative, and it creates this plasma field between them. And that breaks down different gases that are passing through it, different volatile organic compounds, whether it's ammonia, formaldehyde, and there's other varieties of them. And then it also, that plasma field affects the electrons on the passing atoms, and that's what gives them the charge. And that charge does a number of different things. The charge causes particles to become charged and stick together, basically, agglomeration. And that way your filters end up being more effective because there's larger particles coming back. And it also, when it interacts with a virus or bacteria, it grabs a hydrogen from it, especially with the charged oxygen, and that deactivates it.
Yeah, so in that case, it doesn't actually kill the bacteria per se, but it does neuter it. So it limits its ability to reproduce at that point, which is the real threat with most of the viruses and bacteria. So it renders it neutral.
Here's a picture of an actual installation. Typically would mount it next to a fan, and those charged particles would then get distributed through the ductwork and throughout the space. The particles, they don't last extremely long, but within that time frame, they get out in the space and they do their job, and they get replenished by more that are continually coming through the duct. The goal is to have roughly 2,000 ions per cubic centimeter within a space, but because of how short how short the lifespan is, that the readings are always going to vary quite a lot. And if you have any background radon, even small amounts of radon, that's going to affect ion readers. It's not necessarily providing additional beneficial ions, but it's just going to affect meters quite a lot. So the ions that we're talking about, they're the same as naturally occurring ions. So whether it's near waterfalls and forests and things like that, you typically have high levels of ions. Outdoor air typically has good levels of ions, but then you get into places that are either more polluted or inside, you could also say that's polluted. In many cases, the ion levels go down quite a lot. So we're essentially replenishing the ions within a space.
And that's one of the attractive parts. I mean, when we first started looking into this idea, you know, when you're near the ocean or you are high up in the mountains and in the woods, you notice that clear, fresh smell, and the air just seems better than when you're in town or in the city. And when you start to look at the role the ions play, you know, the more human activity there is in a specific area, the more dirt that we create. There's more dust in the air, there's more pollutants in the air. You've got fumes from cars and heating your building and all the things that we do. And it depletes the ions, the stream of ions that would, the same reason that the mountain air feels clean, the ions are trying to do that in the occupied areas as well, but they just can't keep up. So we need to create more ions. It seemed like a pretty simple strategy to us in principle. And when you look at that, you know, Mark pointed out these ions lasting 60 seconds. That's important for a couple of reasons. Number one, they do have, by mounting a single unit within an air handler, you know, it probably only takes 10 to 15 seconds for that air, once the ions are generated, to get out into your space. And that gives the rest of the time it's actually active within the breathing zone for your occupancy, so that it does get to the source. So this separates it from many of the treatment means, which are really only effective at the coil or within the unit level. Secondly, it gives you, since these things only live a minute, and we're trying to maintain this level of 2,000, it gives you an idea. We're actually generating hundreds of thousands of these ions in order to be able to meet that requirement. So again, when we were looking at the type of product we wanted to use, again, we came back to GPS. First of all, they were forthright in delivering all this information. We didn't feel like we had to pry any of it out of them, but also their delivery volumes are very high. So again, we feel that it's a good selection in order to try to maintain that level within the rooms.
Yeah, that's a very good point. For curiosity, I even went on Amazon and looked up, okay, if I do a search for ion generators, see what I find. And what you end up seeing in there is ones that, first of all, they don't meet the UL, and they also don't generate very many ions. So even if they did meet the UL, they wouldn't be very effective, because they couldn't create enough ions to be effective. So we just finished talking about what we can do to mitigate the viruses that might be in the air between you and another person. What else can we do? With what remains? Well, we can treat all the air that gets distributed. So especially, say, in the case of enclosed offices, so that anything that gets brought back to the air handler can be dealt with, and then anything that comes back out and into the offices from a supply diffuser is cleansed. So we're looking at a few different options there. One will be looking at outdoor air for dilution, and the other will be increasing filter efficiencies. Also, just wanted to mention UV. UV in ductwork is definitely an option, and there is some effectiveness there. There's two different types to look at. One is a coil surface disinfection, and that's what's been around for quite a while, and that's, when you think of UV in an HVAC unit, that's what you typically think about. But the purpose of that is more for cleaning the surface of the coils in the drain pan. There's not enough intensity there to disinfect the entire airstream that's coming through. Versus the induct air disinfection, you have a whole lot more UV, and that can take care of the air going through through the ductwork. It's just a different style of system, and you also have that many more bulbs that end up needing to be replaced. So outdoor air for dilution. Outdoor air is definitely an important component of reducing risk. And if your outdoor air is shut off, you want to make sure that that gets opened back up again. But you also need to realize that there are consequences of opening your outdoor air beyond what it was initially designed for, especially during extreme cold, extreme humidity. So ASHRAE's recommendation is increasing outdoor air to the maximum allowable per air handling unit. Here's a caveat: without compromising the indoor thermal comfort for learning environment. That's where you really need to have engineering take a look at what are the limitations of the equipment that you have. Can it handle more outdoor air? And if not, well, what do you do? Do you look at energy recovery to be able, ventilators to increase outdoor air? Do you have to add dehumidification? Or do you look at other strategies? But you should at least have some outdoor air into your spaces for dilution. Also another thing is run your fans constantly. That also goes along with the bipolar ionization. You want to run the fans so that the ions get distributed. With outdoor air, you want to run the fans so that the outdoor air gets distributed and everything gets diluted. And then when we talk about filtration, again, you want to run the fans so that the air is continually being filtered. So, filters. When you think about high quality filtration, most people's minds, the first type of filter they think about is a HEPA filter. Well, it may not be the best application for most scenarios that people actually have in offices and most businesses, because HEPA filters have extremely high pressure drops. So this chart over here shows the face velocity of air through a HEPA filter and how much pressure drop there is through it. Well, if we'd use it at its normal application, your air handler wouldn't even be able to push the rated air through the filter, let alone through the coils and the ductwork and to come back again. So you'd have to extremely oversize the HEPAs and potentially increase your fan. So it's not really an option for most cases, unless it's say a hospital or some other type of facility like that really must have HEPA filtration.
And the other piece I'll add to that is remember again that while the virus molecule is extremely small, it's almost never alone. So it's always linked to a larger molecule that puts it up in the 1 micron or slightly larger size. So having these filters that are viable all the way down to 0.3 microns it is an overkill situation for what you're trying to target. There are lesser rated filters that'll still be effective for the virus itself in the form that it will appear within your buildings, and it is a lesser impact to your system. Now that it doesn't change the fact that your system still needs to be able to handle the additional pressure drop. So it's something that you still need to evaluate with your service provider to make sure that it does suit your application. But there's a lot more room for these MERV 13 level filters. It will be just as effective for what you're shooting for and a lot more applicable.
Because as this chart shows right here, we're looking at the different particle sizes and what the efficiency is of the filters. So you look at a MERV 13 filter, and on the right-hand side of the aerosols size particle, with the 1 micron, you're looking at over 90% of those particles are being caught by the filter. You go to a MERV 14 and you're close to maybe 98% are being caught by the filter. Your typical filters will be, say, a MERV 6 or a MERV 8, and you're less than 40%. So upgrading filters will make a huge difference. And most of the time, your air handlers will be fine with a MERV 13 and MERV 14. Not quite all the time, but just about all the time. Along with that, another thing you need to take a look at is the filter rack seals, so that air isn't bypassing and getting around the filters. You want to make sure that the air is actually going through the filter and that those particles are getting caught. So this is a summary of what we were just discussing, of how to reduce exposure by first making sure that the SARS-CoV-2 particles, virus particles, don't get into the air in the first place, by masks and face coverings and just staying away if you're sick. And then how do we deal with, to treat the air within the room? About the only thing that's going to work well will be the bipolar ionization. And then how do we handle what remains and what's being recirculated by the HVAC system? Outdoor air for dilution and increased filtration to MERV 13 or 14.
Yeah, one thing I would add to that is, so with number one, the reduced exposure, one thing we didn't mention, which is worth spending a little bit of time on, is the no touch, is in areas of your business where you can go to a no touch policy, whether it's sensor operated faucets, lighting, door entry, block open doors that where you do not require, it's not required for fire protection or privacy or any of those kind of things. Again, the transmission through contact is a piece of that, and I think it's something you want to consider in your overall strategy.
Then I guess we can open it up for questions.
Yep.
I don't have any been submitted.
We haven't had it come through the email yet, and I don't see any on the chat. But yeah, at this time, if you want to throw out any questions, we'll take as much time as we need to here for questions from our guests.
David has a question.
Go ahead, Dave.
Dave. Yeah.
I don't know if, Dave, are you able to unmute yourself?
Is it better to use ceiling fans during these times to mix the air? Is that making things worse? Or is it better to leave them off and just use the flow of the HVA system to try and draw things away?
That's a good question. I know some of the early discussions from ASHRAE was to limit how much fans are used because of it blowing virus particles from one person to another person and stirring up the air rather than letting those particles settle.
Did they come to a final recommendation then? And if you're using the ionization, is it better to have the fans on to distribute the ions?
Right. I haven't heard further from ASHRAE regarding their recommendations, but I would say to just use the general HVAC fans for distributing the bipolar ionization.
Yeah, and I'd agree with that. I think this falls into no history, no conclusions from anyone, and I think here's where you need to start considering implications. So if if the fan is more like an air mover for personal cooling and your velocities are fairly high, I would say that you want to restrict using those fans because you don't want to re-entrain any of the particles that may have already fallen out and increase transfer that way. If the air velocities are relatively low and you're not, say, moving the air in very similar to or no greater a fashion than the air handler would through the room, I think it could be considered a benefit. The bottom line is we don't, a lot of this stuff, even at this point in time, we have no actual data to support it. So I think you just need to try to apply common sense and reason to it and think about the implication one way or the other. At least that's my opinion.
Yes, in talking about our sanctuary, which is a large auditorium, the HVAC ducts are in the ceiling. So in the winter, all your recirculated air is at the ceiling, and because of the hot air rising, so to disperse the ions, I would think we would want to run our ceiling fans as we currently do at various low speeds to bring that hot air down. But I just was sort of a borderline thing, and I wanted to get your advice.
Sure. Based on that application, that does make sense for trying to make sure that you get the circulation down where it needs to be. But
So we're
again,
trying to
more
limit
at
the
a low velocity.
Don't feel a draft.
Mhm.
Thank you.
Thanks, Dave. Other questions?
In general, I think, the question from Dave raises a good point, and, what we've assembled here, we've used our best judgment, and it is judgment. There's not a whole lot of fact in general. And I think as a consumer and as someone who's in charge of a building or who's, has public interaction, I really think the onus is on everybody to stay grounded. Don't allow yourself to get caught up in the hype of the media in what's going on right now. Do your research, dig into the facts, and if there's, in the cases, and many of them are that way, in the cases where there is not a distinct direction or factual data to back you up, I really think that's, again, we're advocating, it's partnerships, it's bringing in, having discussion with the people that you value in the systems that are in the building, and just talking it through. What makes sense, what doesn't make sense? How do you, what's the best use of your funds? What's your end goal? So, many times in situations like this, there's no clear-cut path, but when you discuss it as a group, you can still reach a policy of what you will do, and it will improve the situation. It's just a process that I think we need to be able to go through in order to get to the end game.
Thanks, Dave. Did you have another question?
It's one I'll probably call you about. It was just a technical thing about your chart on the filtration efficiency. I was curious why the efficiency seems to go up again below, I think it was 1/10 of a micron or 1/10 of a millimeter.
It is interesting. There's different methods of how particles actually stick to filters, and there's a particular size where filters in general are all the least effective. It's where the method of capture is dropping off from one style and then picks up on the other style. In general, the larger a particle is, the easier it is to capture. but some of the extremely small ones that are smaller than COVID also get attracted to filters.
Yeah.
Any other questions?
And actually, I might as well also state that we've mentioned a lot of SARS-CoV-2, but this isn't just effective, or these strategies aren't just effective against that. It also, whether it's the flu, whether it's other viruses, other bacteria, and just indoor air quality in general, these will help with all that.
So we'll take some more time here, and I'll kind of run through some other things that we had here. Is, to the point where you're an existing preventive maintenance customer, and we would likely have most of your equipment information, but we are providing what we're calling, it's essentially a courtesy evaluation for you, and or a free building assessment relative to your indoor air quality. And really what that ends up looking like is, you could reach out to us, through our website, or, if you're a preventive maintenance customer, through your account manager, and essentially have a conversation around, specific concerns that you would want to have, whether it's COVID related or other indoor air quality issues, kind of what your tolerance is for increased operating costs, potentially depending on which direction you choose, any existing actions you've already taken relative to air purification, and then deliver like a report summarizing, summarizing what you have, what your concerns are, and general recommendations that we have. Once we get to a spot where we would need to, measure the outdoor air volume, or recording temps or VOCs and other load calcs, that would be at a spot where we, help you understand what the cost would look like, to that point. But really appreciate everyone's time. This is something, that even several months into it, things are continually changing. So we're continually learning. And Mark and George are doing an awesome job, staying on top of it as much as we can with new information. But you can reach out to us through our website and through any one of our offices. Really happy to help. I had a comment that came in there through the chat. To the point that we have your email, we'd be happy to share this presentation with you. But even if you just want to have a conversation or other questions, reach out to us, and we'd love to help you out as much as we can. And I do have a couple of other conversations that. I'm sorry, these are just, I received a couple of requests here for sharing the webinar. And again, if you can just email me directly, we'll share them. Any other questions that have come up? Just give like another 30 seconds to a minute. And if there are no questions, again, feel free to reach out to us. And otherwise, thank you so much for being a part of the webinar. And thanks a lot to George and Mark for time.
Positive stream.